Okay, so let's talk about the Winnow convergence bound. So we start by assuming that all the data live in a box because you can always normalize them so that they do. And then again, similar to perceptron, we're going to assume that there is a hyperplane that separates all the data really well. Okay, so assume that there's a W star such that the data are separated with a margin, perfectly separated, with a margin of delta, at least delta. Okay. So all the points are on the correct side of the decision boundary and they're far away from it by at least delta. Okay, so this is just separates. And also we need the weight vectors to be non-negative. Okay, because again, we're doing exponential weights, so all of the weight vectors, they form a discrete probability distribution and they are all non-negative. Okay. Speaking of discrete probability distributions, the one norm has to be 1. You have to add up to 1, the values. Okay. So the bound is the Winnow algorithm makes at most this many mistakes. So t less than the log of p, where again p is the number of features, and delta, where again delta is this margin from up here, the separating margin. So if the margin is bigger, the bound gets better. Okay, so the fewer mistakes Winnow makes. Okay. Log of 2 over e to the eta plus e to the negative eta. And that's the number of mistakes. Okay, because remember, each round is a mistake. So t, the number of rounds where you're done, is that many mistakes. Okay, and we'll talk about how similar this is to the perceptron in a bit.